If you want to know everything about factorization of complex algebraic expression, then I want you to stick to the end of this video, because in this video I'm going to be showing you that in detail. This class is a must. You just have to see this class to the end. Okay, AC Okocha is my name, and this is just academic mathematics, where we make you a mathematics genius. Today we're looking at another dimension of factorization. This time around, factorization of quadratic expression that is with greater than 2 exponents. If you notice, this is raised to the power of 3. So we're looking at the ones that are greater than 2, like 3, 4, 5, and so on. Okay. Let's go straight to it. Now, we have something here. If you look at this sequel from what we did in our last class, I told you that you always look out for a way to, factorize any given question. If you look at this question carefully, you will notice that these two brackets are the same. And because these two brackets are the same, that makes it easy, because we can factor that out. This is what I mean. So here now, we can say that B plus C is out. What will remain after B plus C is out will remain A squared. Then it will remain minus B plus C square. There are 3 of them here. So 1 is out, remaining 2. This one is out. Can you see? Now this bracket, this big bracket, this square minus this square, from our last class, of course, you know that it means difference of 2 square. So this is B plus C bracket. Apply difference of 2 square here. You have A minus B plus C times A plus B plus C by application of difference of 2 square. So we have B plus C. If you open the bracket, you have A minus B minus C bracket A plus B plus C. This is the factorization of this. This is the answer. It's the same thing I want to write anyway. A minus B minus C, A plus B plus C. That is it. That brings us to something similar. Look at number 2. Something similar. Very similar. Number 2, we're asked to factorize this. If you look at this one square, this 9 here is a perfect square. This is square. So we can write this as 3A square minus A square minus 4 square. Then we can apply difference of 2 square direct. So we have 3A minus A square minus 4 times 3A plus A square minus 4. So we can actually open the bracket there. We have that 3A minus A square plus 4 bracket 3A plus A square minus 4. If we rewrite this now, this one means minus A square plus 3A plus 4 and A square plus 3A minus 4. Let's factorize this. Let's see if it can be factorized. Add to give you 3 times to give you minus 4. That should be minus 4 plus 1. No, 4 plus 1. 4 minus 1. 4 minus 1 is 3. 4 times minus 1 is minus 4. So that will work. So we have minus A square. We say 4 minus 1. That is minus A plus 4A. 4 minus 1 plus 4. That is for that. Then for this one, add to give you 3 times to give you -4. I think it's the same thing. 4 minus 1. A square minus A plus 4A minus 4. What is common here? Minus A is out. What will remain here? It will remain A plus 1. Plus 4 is out. It will remain A plus 1. How about this one? A is out. It will remain A minus 1. Plus 4 is out. It will remain A minus 1. Factor A out. A plus 1 is out. What will remain? It will remain minus A plus 4. And the same thing here. A minus 1 is out. It will remain A plus 4. It will remain A plus 4. I think we can just we can leave it like that, or we can write it to, since minus is here, we can start with 4, which is still the same thing. Both of them are actually difference of 2 squared 2. This is A plus 1. Although this is correct here, you can stop there. And this is A minus 1, difference of 2 squared. I can rewrite this as 4 minus A, and I can rewrite this as 4 plus A, another difference of 2 squared. So in summary, this is A, but there is no need. We just have to stop here. But because taking it to the other form is going back, I wanted to say A square minus 1 times, what was it now? 16 minus A square. It is this that also gives birth to this, but this is the best place to stop. So that is it. How to factorize this now. Are you following? You can stop here, you can stop here. Any of these two will give you this. Okay. So you can always go through this over and over to understand. I'll show you another example. Number 2 now. I'll show you number 1A, 1B. This time around number 2. Look at this. We are asked to factorize this. And there is something I need to show you, very important. The way we have difference of 2 square for quadratic. When you have cubic function, take note of these two. I want to give you now. Just take note of this identity. A cube minus B cube is equals to A minus B times A square plus AB plus B square. If you expand this is what you get. It's an identity. Just the way we have difference of 2 square. We have this. Take note of this. Then take note of this one. The one of plus is the same thing as A plus B. Here is A square minus AB plus B square. This, the expansion of this will give you this. We are going to apply this identity now. Now that brings me to 64 minus A cube B cube. Now 64, cube root of 64 means 4. 4 times 4 times 4 is 64. So that is 4 raised to the power of what? 3 minus AB raised to the power of 3. So if we apply this one, if we apply this to this first rule, we are going to get 4 minus AB times 4 square plus 4AB plus AB square. Are you with me? That is the expansion. Applying this. Assume that this is A, this is B. Put it in this place, you will get this. So this is now 4 minus AB bracket 16 16 plus 4ab plus a square b square. Look at example 3 here. Look at example 3. So example 3, we're applying the same thing we just did there. If you look at this very well, carefully, if you look at this, you will notice that a is common here. So let's bring out a. If a is outside, what will remain? A raised to the power of 3 minus 3, 4, 3. Are you following? So we are going to find the cube root of 3, 4, 3. And the cube root of 3, 4, 3 will give us what? 7. That means this one is 7 raised to the power of 3. This is what I mean. A bracket a raised to the power of 3 minus 7 raised to the power of 3. So you apply that law. The law that states that a raised to the power of 3 minus b raised to the power of 3 is equals to a minus b times a square plus ab plus b square. Don't forget this. Don't forget this. So let's move on. If we apply this here, we'll have that a bracket. What's this? A minus b. A minus 7. Because this a is this b is 7 now. Anywhere you see b, just put 7. A minus 7 bracket a square plus 7a plus 7 square. So we have a bracket a minus 7 times a square plus 7a plus 49. Can this be factorized? Add to give you 7. Add times to give you 49. 49 is only 7 that can go into 49. 7 and 7 go there, 7. And there is no combination like that. So the final answer should be a bracket a minus 7, then a square plus 7a plus 49. Are you following now? Okay, now look at this. These two. For this example 4, let's take on this first 2, and then we'll take on this last 2. Because this one, cube, this square, that should work. The other method we are trying to use will not give us what we need. So watch this now. So this is a raised to the power of 3 minus 3b raised to the power of 3 plus 2a square b minus 6ab square. So this one, we know the rule already. I've shown you 2 already. If we apply the identity of this, we will now get a minus 3b times a square plus 3ab plus 3b square. That is the identity of this. Then plus this one, what is common? 2ab. What will remain? It will remain a minus 3b. Can you see that now? This one is working because these two have something in common. So if you take this one out, you have a minus 3b, then bracket, here is a square plus 3ab plus 9b square plus 2ab. Are you following now? So this is a minus 3b, then a square. These two are in the same family. These two. 3 plus 2 will give me plus 5ab, then what? Plus 9b squared. So let's see if we can factorize this. If we can factorize it, then we can do it. We can go ahead and do it. If not, we'll just have to leave it like this. So add to give you 5, times will give you 9. Anything like that? I don't think so. I don't think so. Add to give you 5, times will give you 9. I don't think so. So we'll leave the answer like this. There is nothing we can add. We can't split this one. Assuming we can split this one into 2, then we will have been able to factorize this one further. I get what I'm saying? We will have been able to factorize that one further. But since we cannot split this one into 2, then we'll have to stop here as the answer. That brings us to number 5. Look at number 5. Now, when you see this, anytime you see the one that has just one variable, you think of what to do, because sometimes it can be easy when you see one variable. What do I mean by that? I can rewrite this now as a raised to the power of 3 square minus 7a raised to the power of 3 minus 8. By me rewriting this, I can now say that p is equals to a raised to the power of 3. Let p be equals to a raised to the power of 3. So if that is the case, we have p squared minus 7p minus 8. Is it making sense? So we'll factorize this. Add to give you minus 8. 7 times will give you minus 8. Minus 8 plus 1. Minus 8 plus 1 will work. So we'll have p squared minus 8p minus plus p minus 8. What is common here? P. What will remain? P minus 8. What is common here? 1. What will remain? P minus 8. We'll bring out the common one outside. That is p plus 1 times p minus 8. When you factor p minus 8 out, it will remain p plus 1. Are you with me now? Now, we recall that p is equals to a raised to the power of 3. So we have a raised to the power of 3 plus 1 times a raised to the power of 3 minus 8. Interesting, is it not? Now we can still rewrite this one further as a raised to the power of 3 plus 1 raised to the power of 3. Then a raised to the power of 3 minus 2 raised to the power of 3. That will give you 8 now. 2 raised to the power of 3 is 8. So you apply the identity of this. The identity of this one means a plus 1 times a square plus a times 1, that is a, then plus 1 square times this one, a minus 2 bracket, no, this one, this place is minus, not plus. This is plus, so here is minus. But this one is plus. Here is a square plus 2a plus 2 square. Are you seeing it now? Wow, I like this. So this is a plus 1, a square minus a plus 1, a minus 2, a square plus 2a plus 4. Can we factorize this? Add to give you 1, times to give you 1. There is nothing like that. Add to give you 2, times to give you 4. There is nothing like that also. So we conclude that the answer is a plus 1 times a minus 2 times a square minus a plus 1 times a square minus 2a plus 4. this is what you will get when you factorize that. Is that clear? Let's conclude this class. There is a square. The example does not end in 6, so, but I want to just stop in 6. There is a square to this class. 7, 8, 9, 10, 11, 12. Make sure you see those examples. But let's conclude with this. This example 6. Example 6 look like example 7. But you need to check. That is why I say what works for one may not work for another. So you need to be very versatile and you need to think fast. Or else you won't be able to do anything. If you look at this now, I will have said let's make this one s squared raised to the power of 2. Then anywhere you see s squared, call it p. But can you factorize? No, because of 1 here. There is nothing you will add to give you 1 times to give you 1. It won't work. It won't work. It won't work. So the question now is, what exactly do we do? This one is a bit technical, but I'll tell you what we are going to do. What we are going to do is that we are going to replace this number here, this s squared, with 2s minus 1. And I will tell you why. So this s raised to the power of 4 plus 2s squared minus x squared. So this 2 now is still this one. 2 minus 1 will give you 1. Then plus 1. Now, with this and this, there is a relation. This is what I mean. S raised to the power of 4 plus 2s squared plus 1. Then minus s squared. This one you are seeing now, like this, actually means s squared plus 1 times s squared plus 1. If you expand this, this is what you will get. S times s. S squared times s squared, s raised to the power of 4. S squared, if you add it, you get this. 1 times 1, 1. Then minus this. So this can be written as this plus this square minus s squared. Then you can apply difference of 2 square. That this is s squared plus 1 minus x, then s squared plus 1 plus x. So we write the answer as s squared plus 1 minus x, then s squared plus 1 plus x. That is correct, but we can write it as s squared minus s plus 1 times s squared plus s plus 1. If you expand this, this is what it will give you. I'm going to stop here. In our next class, we are going to be doing examples 7, 8, 9, 10. Very complex. You need to see those ones, please. Make sure you subscribe if you have not subscribed. The handle is Just Academic Mathematics. Follow us on Facebook, Just Academic Mathematics. If you want a one-on-one tutorial, I am available. Send me a message via WhatsApp. Thank you. See you in our next class.